Okay, well, I think nobody will know what I'm talking about today. So we'll see. I will explain some stuff. I wasn't expecting that. But anyway, thank you for inviting me here today. My name is Gareth, and I'm a computation designer at Hawkins Brown, which is an architecture company. So I am, wait a second, something's wrong with my, cool. Okay, this is just trying to make me look smaller, but anyway. I also have my own fashion brand. It's called Gareth Volka, which specializes in digitally fabricated garments. So today's presentation is a mixture of my personal work and my work for Hawkins Brown. So I consider my journey pretty different from other in the industry, and hence why the topic of this presentation. So I was in the academic for like a decade, did research after research, and my undergrad was in environmental science and computer science with a minor in mathematics, and I did a master in robotic engineering and then in architecture at Bartlett. So that was 4.5 degree later. So I can't really brag that I made a lot of good decisions in life, but I certainly have a lot of interests, which made my current role at HB like pretty interesting later on. So I need to start from the beginning to show the artistic and computational progression. So I started making environmental conscious like sculpture installation while I was studying environmental science. This is at Bard College in upstate New York. It was a really hippie school, so I think that helped shape me into an artist. And this is a large-scale installation done in 2015 titled Invasion. So it highlights 4 invasive species in upstate New York. And Houdini is completed a year later after 3 months. So it was a 3-meter tall sculpture installation made by recycled newspapers. Took a lot of effort to go through many dumpsters every day to find recycled newspaper for sure. So then I started exploring digital arts, starting from like Google shopping, like Google Earth photoshopping Google Earth images, which actually gave me a ton of followers on Instagram back in the days. And then it started evolving into like broader range of subjects, mostly nature and architecture focused. So I will come back to the part of my study in computer science and robotics later. This is in architecture. So I studied architecture at Cornell for 1 year in 2020. And this is a design exploration study from a study of jellyfish as a physical sculptural representation, and then evolved into a floating pavilion. And this piece is called Instrument of Flyweight Typology. It proposed a megastructure with no usage of glass panels, which attribute as the #1 bird killer nowadays. It emulates a forest canopy system, and the project was based on algorithmically generated simulation of Boyd's movements and several mathematical models. So this is another bird-related project, a library in Philadelphia featuring bird watching tower. And very unfortunately, the highly computational approach was not really well received at Cornell. You probably don't know what I'm talking about, but like it's an architecture school. So I left 1 year later for Bartlett, which is another architecture school at UCL. This is my final project at Bartlett. It was a rammed earth social housing complex in Las Vegas, but I'll focus on the computational part here. So it's starting from an algorithm called wave function collapse. It's commonly used in gaming like map generations, where you define the rule of where each tile can be placed adjacent to other tiles. For example, you have a grass tile. It can be placed right next to a mountain tile, but not to like, for example, a house roofing tile. That's not allowed. So, and then you aggregate to a whole map. We code a wave function collapse in Unity for like floor plan study. So we integrate game engines in this design processes. And next we use machine learning for massings. You guys probably know, but I know many people in architecture throw this word around without knowing what it is. And now you probably also knows after the first presentation. Anyway, it works as if you learn from data without explicit rules. It's like a cookbook, a cook recipe is like a bunch of explicit rules. But what happened in your bodies, on the contrary, like inside your body, you probably don't know what's going on, but you're doing certain actions. So that's without explicit rules. You do those actions sometimes by following. And that's kind of like the essence of machine learning. It emulates the end result without being instructed by an explicit rule sets. So in this case, we draw like 500 images by hand based on the study of Barbican like orientation. And the machine learning algorithm, which is called pix-to-pix in this case. We also use ML agent in Unity. It's a built-in function in Unity. Pix-to-pix is based on Python. It learns through some algorithms that map out the relationship between pixels adjacency, for example, like data like colors and brightness, and learn it that way. So later in this project, we attempt to like using robotic arm to do some like automation process, automating the rammed earth process. This is a physical model and material studies. Structural components, I thought everyone will be structural engineer. Anyone here? Okay, never mind. I'll pass this part as well. Some interiors, exteriors. This is a project, again, at my uni called Glulam Weaver. It's a timber skyscraper for the Beehive skyscraper competition. It was at the beginning of the year. Beginning of last year, actually. So AI was just start getting everywhere. If you stare long enough into this image, you will see AI everywhere. Like, everywhere. Same with the rest of this projects. There's some timber studies. And yeah, I bring this project up just to showcase like the AI usage in academic projects, mostly in rendering, architecture. That's the most significant usage at the moment. But people are migrating to 3D objects and also into videos. The Luma new model came out 2 weeks ago, right? This is another mass timber megastructure I designed at Bartlett using algorithmic design. So basic coding to construct these pieces. So this is reimagined Madison Square Garden in New York City. The demolition of the old Penn Station is always controversial, you might heard. But the status of Madison Square Garden also is pretty iconic because it's a place for NBA and it's a concert hall. So for this project, I propose a mixed-use hub with hotel, transportation, arena, and air train to Central Station and Hudson Yard, all in one piece. And featuring a fluidity like new concert hall now like separated from the basketball arena below. And Houdini, which is a VFX software, mostly used by Hollywood, but it was pretty popular tool at my university, Bartlett, because they love like really cool technical tools. So this was a project that was constructed with Houdini algorithms. It gave like brand new possibility of organic structures and mass data processing, which is traditionally the weakness of a software we're using architecture called Rhino, and not to mention Revit, the building software. It's even worse. It crashes all the time. So this piece is called Central Park Lone Ranger. And this piece is called Strange in Your Perfect World. It's another Houdini project I made at Bartlett. So finally, I went to a firm called Hawkins Brown. Now as an architect, my role is computational designer. And I started a year ago, and yeah, basically I'm the only person in the computational team at the moment. So I'm going to navigate a little bit carefully here because most projects are confidential. So we mostly do educational facilities, like University campus at Cambridge, Oxford, and UCL. We designed the Bartlett building where I studied. Those projects takes forever because it's university, so they make decisions very slowly. So everything I touched over the past year, all in progress. That's why hence confidential. Besides this one was our new shop front. We just moved to our new office last September, and this one was done in a few weeks. So I helped an architect basically to convert a hand drawing into something digital so you can explore different design probability just by sliding some parameter sliders. And in this case, we show some different design options and also color options after digitizing it. So my work at Hawkins Brown, I'm mostly dividing into 3 categories: design, computation, automation, and research exploration. So majority of my tasks are automation because, yeah, the building construction process takes so long. So the opportunity only came every so often. So automation including like develop like Revit plugin, Rhino plugin, Grasshopper plugin, those are all architecture software. Anyone heard of them? Okay, great, perfect, finally. Great, so yeah, I code those because technically I signed up for an architect job, but they heard I can code. So yeah, I'm doing programmer job right now and get paid architect salary. Yeah, I'll see what will happen in the future, but anyway, that's what happens right now. Yeah, the research exploration aspect gave my role a lot of freedom in incorporating a lot of my other skills that I'm really interested in, such as gaming, AR presentation. Currently, I'm exploring a tool. It's called Hologram. Basically, bring AR from your Grasshopper and you can still control it. You're building parametrically, you can control it parametrically and bring it to any Android devices. They just put that behind a paywall. It's kind of a shame, but yeah. And also some digital fabrication. And that brings us up the next part. This is a little pen plotter I built at HB for a pinup party. I think my most interesting project there, I get to build a robot for an architecture firm. Like, use it for what though, right? But it looks cool. I wrote a plugin called Reflector back at Cornell many years ago. So it was published on Food for Rhino. There are not that many downloads, unfortunately, but it can create organic shapes in just a few seconds by reflecting a mesh some infinite amount of time. So like that human centipede over there, but yeah, and that Disney castle over there, that's what this plugin does. Most of my prior to architecture experience were in research. So I did a lot of robotic research with timber glulam weaving at Cornell. And I wrote a painting robot, which I'm going to show next at Case Western Reserve University, and a bunch of biology research beforehand. That was my first few years. Yeah. So let me see if this plays. Oh, I don't have internet. I forgot. Oh my gosh. Right. There's no Wi-Fi here, but this is a robot we built for the Cleveland Ingenuity Festival. I'm mostly in charge of building the pneumatic system. I'm not too good with the circuit board behind. I also developed the software a little bit. So yeah, the first thing we printed out was a money sign. This thing cost $500,000. So yeah, hopefully we'll get that money back. But that was the initial idea. Got some research grant, which is great. And also Hacksum. I love Hacksum. Back when I was studying computer science, we mostly interested in like some bionic devices based on Arduino. So this one controls, we're using to play some game called Cookie something. I forgot. I never play games, but like it controls a mouse. So yeah. And we also use it to pen like VR, Google Map. That was like 6 years ago. That was a modular synthesizer. Similar to those 70s modular synthesizer we're trying to play. You can attach to your fingers as well. And my master's thesis back in computer science years ago was like, back in robotic engineering years ago was studying origami movement. I built a like low-cost origami robots that has a pneumatic system that can be inflated. I started adapting like Grasshopper and those architecture tool way before I studied architecture. And is this also not working? Anyway, this is, if the video works, you will see the robot crawling forward based on pneumatic contraction and the expansion. So last summer, I did this like, oops, I went a little bit over time. I'll wrap it up. So at A digital like prototyping lab, A is right there. It's architecture school right there. We did some 3D printed clay. And this year, I'm still collaborating with them. We're doing some bioplastics. It's kind of on trend right now. So yeah, but we're trying to combine it with robotic arm and do 3D printing with bioplastics. Don't have any end results yet, so I don't have any images right here. Okay, my last part, my new venture, fashion design. Started as a Houdini fashion designer. Then I play with fabrication because that's like really my strengths and my interest. And so this is a 3D printed dress that took me a whole year to make last year. I made it 4 times because it kept failing. And I have to redesign the structural system. And eventually, I put it on the runway. This is a model London fashion show earlier this year. And together with some other pieces. So this is metal dress made with aluminium based on algorithm called reaction diffusion. And this is another 3D printed dress. I collaborate with architect Louisa Pierce. We explore the mathematical concept of hyperbolic space. Essentially, you squeeze a 5-dimensional space into a 4-dimension tiling system, resulting in some warping of the space. And this piece is called Gossamer. It's an origami dress collaborated with an origami genius called Darrow Bedford. He focused on the micro pattern where I focus on the macro pattern. And we use digital fabrication workflow to make it happen, essentially a lot of laser cutting. And here's some early prototyping. Imagine with AI guiding our design, use Comfy UI and ControlNet based on our samples of physical model. So we took picture of physical model, we bring it to AI, trying to generate something interesting based on that pattern, because the pattern stays the same. So this piece was inspired by the vernacular architecture constructed from earthwood straw and decorated by rich motif and symbol in West Africa. So those are some sample images that we reference from. And finally, this 3D printed dress, Minor Symphony, shown at the London Fashion Day just 2 months ago. It's my latest work, basically. And that's pretty much all. Thank you so much. Yeah.